everyone, welcome back to Python programming series. This is the part 1 video from module 4. Before starting, if you are new to explore electronics, then subscribe to it for more VTU syllabus explanations. Let us start with the topics covered in this video. Random numbers, time module, math module, creating your own modules and namespaces. Scope and lookup rules, attributes and the dot operator, three import statement variants, mutable versus immutable and aliasing. These are all the topics covered in this video. Let us start with the random numbers. We use random numbers in many programs such as games. In games we use dice. In dice we use random numbers, coin flip and number pick. And shuffling cards, there also we use the random numbers. Random enemy positions in the games and simulating rainfall for dam projects and internet banking encryption. In these programs we use the random numbers, and Python has a random module for this. To create for random numbers we have a random module. Let us see an example how exactly the random numbers works. Import random RNG, that is range, is equal to random dot random function I am using. Dice thrown is equal to range dot random range, that is 1 to 7. Here which gives 1 to 6. 1 is included and 7 is excluded. Clear? The random numbers between 1 to 7. Delay is equal to range dot random function into 5 dot 0, which means it is a floating data type. Clear? Here it gives 0.0 to 5.0 random numbers. Clear? Y means I have taken the range that is 1 to 7. It will take only 1 to 6. And I have multiplied with the random numbers 5.0. It will multiply with this number and gives the result. Clear? And the random range works like range function only. Lower limit included, upper limit excluded. I have told, right, this is included and the upper limit is excluded. All numbers equally likely, which means uniform distribution. Whatever the number I will take, it will multiply with the 5 and gives the result. Optional step value, which means it is not a standard term. Here, for example, random odd is equal to range dot random range 100 and 2 I have taken, which means it is lesser than 100 because 100 is the max value I have taken. It should be less than 100. The random function gives a floating number between 0.0 and 1.0. Here the 0 is included and 1 is excluded. And we can scale it. For example, look at numbers between 0.0 and 5.0. All numbers in that range are equally likely. Clear? Let us see one more example for shuffling a list. Cards is equal to list range, that is 52. The range is 52 because we have 52 cards. Range dot shuffle the cards. Here it will shuffle the pack. Clear with the random numbers? And the next topic is time module. When the program gets bigger, we often ask, is my code efficient? Whenever the code is very complex and bigger, we have to check the efficient of that code. Clear? Correct, right? We can check this by measuring how long an operation takes. We can check the efficient. How can I check the efficient? I can check how long the operation taking. How long this operation taking the time. By this I can easily check the efficient of that code. Python's time module has a clock function for, which means to check how long the operation is taking time. To check the code efficient, we have a clock function in Python's time module. Clear? It turns the number of seconds since the program started. It will start the seconds. It will start with the seconds since the program started. To measure the time, we have call time dot clock function before starting the code. It is t0, time 0, and call it again after the code, that is t1. And we can easily calculate the difference by using ending execution time minus starting execution time. Clear? This shows how long it took. Let us see an example of this. Import time. Here the time module allow for the timing operation. Define do my sum excess. Here it defines a function named do my sum so that accept the iterable excess as a input. And sum is equal to 0. Initialize the variable sum is to 0. And for v in excess, it starts a loop that iterates through each element v in the input excess. After that, sum plus is equal to v. It adds the value of v to the current total in sum during the each loop iteration and returns sum. It exits the function and returns the final calculated sum. After that, sz is equal to, I have a value which sets the variable sz to a 10 million. After that, test data is equal to range sz. Here it creates a range object from 0 to sz and it is used data for the testing. T0 is equal to time dot clock function. Here I am using the clock function. It records the current CPU time before the custom function call. And my result is equal to do my sum test data. It calls my do my sum function with the test data and stores the result in my result. And t1 is equal to time dot clock function. It records the CPU time after the custom function finishes. And print my result is equal to my result time is equal to t1 minus t0. Here it prints the result of the custom function and the time taken for its execution here. Clear? And t2 is equal to time dot clock function. Again it records the CPU time before the built-in function call and their result is equal to sum test data. Here it calls the Python built-in sum function with the test data and store the result in their result. T3 is equal to time dot clock function. Again it records the CPU time after the built-in function finishes. It will print their result is equal to their result time is equal to T3 minus T2. Here it prints the result of the built-in function and the time taken for its execution by calculating T3 minus T2. Clear? For example, here my result is equal to, I'll get, if you observe, for my result this is the time taken and their result this is the time taken in seconds. Our function is about 57% slower than Python's built-in sum and still summing the 10 million numbers in under seconds very fastly. So this is very efficient, which is calculating under seconds, even though 57% slower than the Python's built-in sum function. Clear? And the next topic is math module. What is math module? Here, math module provides common mathematical functions and constants like those on a calculator. For example, sine, cosine, square root, assign, logarithm, log 10 and constants like pi and e. These are all the examples for math module. For example, if I take import math.py, we have a constant value, that is pi value 3.142, and math.e, this is also a constant value which is 2.718. Clear? And math.square root of 2, if I take square root of 2, it will get 1.42. This is a square root of 2. And math.radians of 90, here it converts the degree to the radians and give the solution for that. Clear? Math.sine Again inside that sine function I have math dot radians 90. Here it converts the sine 90. Sine 90 is 1. That's why it will give in the floating point number. Math dot assign of 1.0 into 2. Here it doubles the arc sine. Arc sine of 1. It will give the result that is 3.142. Clear? In Python or like most of the languages, angles are measured in terms of radians only, not in terms of degrees. How to convert that? You have to use mat.radians or the mat.degrees to convert between them. Here the difference from the random or the turtle models. In random and turtle, we create the objects and call the methods. They have the state. And in math functions, those are pure. They have no state or memory. Here we have state of memory. Here they don't have the state or memory. For example, square root of 2 always gives the same result. No need to store that value. It don't have the state or the memory. It will give the result quickly without memorizing. Hence, these are grouped as functions in the math module as not object methods. This is all about the math module. And the next topic is creating your own module. To create your own module, you have to save a Python script with the .py extension. Clear? You have to save that file name as .py extension. For example, here we have saved a script as sequence_tools.py. Define remove at position and sequence. Return sequence position plus sequence and position plus 1. Using the module import sequence tools s is equal to a string. Sequence tools dot remove at 4s. Whatever is there in the fourth position in s, we have to remove that from the sequence tool. Clear? After removing, I will get a string. If I calculate the counting here, that is 0th position, first position I have blank space, in second position I have s, third position I have t, and fourth position I have r. That's why r is removed here. Clear? We have to remove whatever is there in the fourth position in s in the sequence tools. Clear with this? Do not include .py while importing. While importing something, do not include the .py. And Python automatically looks for the files ending with py. If I don't include also, it will look for the files which is ending with the .py extension. The advantages of using this, it helps to divide large programs into smaller, easy to manage the parts. And it keeps related functions together and organize it. And the last topic is namespaces. A namespace is a collection of names, that is identifiers, that belongs to a model, function or a class. Here the namespace is nothing but an identifier and it belongs to a module, function or a class. It groups related items like math functions or random number tools. Here it groups the related items, the math functions or the random number tools together. Each module has its own namespace, so the same name can appear in different modules without conflict. Which means here each module has its own namespace and the same name can appear in the different modules also without any confusions and conflicts. For example, module 1.py, the question is what is the meaning of life, the universe and everything. The answer is 42. Here module 2.py I am taking, the question is what is your question, answer is to seek the holy grail. I am importing two modules here. I am printing all the questions and answers here. Module 1.question, 2.question and 1.question and 1.answer and 2.answer. Here it will print everything in the output. Clear? Here it is completely about the namespaces. Scope and lookup rules. Here the scope means the region of the code where an identifier can be accessed. The identifier means the variable or the function can be accessed. That part is called as scope. We have three important scopes in Python. That is local, global and built-in scope. The lookup rules define the order in which Python searches for a name when it's referenced. This is governed by the LEBG rule. That is local, E means enclosed, enclosing, and G means global, and B means built-in. Clear? Let us understand these in detail. Local scope means identifiers declared inside a function. It is declared inside a function and each function has its own namespace. We have seen the namespaces example, that is module 1 and 2 in the previous part, that is part 1. And local scope means the identifiers declared inside a function. Global means the identifier declared in the current file or a current module. Clear? Global means the identifier declares in the current module or the file. Local means it will declare inside a function. Built-in means Python's built-in identifiers. Here like range and minimum functions which are always available and those are built-in Python. Python uses precedence rules if the same name exists in the multiple scopes. That is, if the same name exists in multiple scopes, that is local, global and built-in, Python uses the precedence rule and it will go from local, after that global and built-in. Clear? After that you can check scopes using local, global and directory. For example, define range n, return 123 into n. Print range of 10, which means it will take n as 10 and print 1230. Clear with the example? Here our global function range overrides the built-in range. So it will print 1230. Clear with the scope and lookup rules? Let us see one more example. N is equal to 10 and m is equal to 3. Define f of n. M is equal to 3. I am taking one more value here. Return n into 2 into n plus m. Print f of 5, n and m. F of 5 means we have f of n. Here the n value will be 5. Here n value will be 5 plus m value will be 7 because I have changed it in this case. That's why 2 into n means 5 plus m means 7. 2 into 5 is 10 plus 7, 17. 17 I will get in the f of 5. N means I have as it is 10, it will print. M means it will go here only. That's why it is 3. Clear with the example? Here n and m inside the function are local. Here m and n inside the function are local and separate from the global n and m. It is separate from the global n and m. After f returns, global n and m remain unchanged. After we return the f of n, the global n and m remains unchanged. That's why it will print as it is 10 and 3 for n and m. Define f of n adds f to the global namespace, so it can be called later. Scope of global n, the line 1 which is equal to the line 1, 2, 6 and 7. Those are hidden inside the functions by local n. Here the redefining built-in names is possible. It is possible, but it is bit confusing. That's why try to avoid it. And the next topic is attributes and the dot operator, which is I have explained in the previous part in detail. Here I'll explain in short. Variables defined inside a module are called attributes of the module. The variables which are defined inside a module, It is called as attributes of the module. Objects also have the attributes, for example, documents and annotation. We can access that attributes using dot operator. Let us see the module 1 dot question. It will access the question attribute in the module 1, and the module 2 dot question, which will access the question attribute in the module 2. Here sequence tools dot remove at, it will access the remove at function in the sequence tools module. Using dotted names gives fully qualified name, specifying exactly which attribute or function is meant. For example, if you observe module 1 dot question, here I am using dotted names here, which is fully qualified name, and I have specified the question and answer. That's why it will access the particular question from that module. Clear with it? And the next topic is 3 important statement variants. Import module, from module import names, and from module import. Let us see examples for each for better understand. Adds the module name to the current namespace. It will add the module name to the current namespace. Access the function using the dot operator. Let us see. Import math. X is equal to math dot square root of 10. I am using dot operator to access the function. Clear? This is import module, and adds the module name to the current namespace. It is adding the module name to the current namespace. This is the import module, and it will give the square root of 10. From module import names, here adds the specific names directly to the current namespace. It can use functions without the module name. The module name itself is not imported. If you observe the example, it is adding the specific names directly to the current namespace, that is cos, sine and square root. And x is equal to square root of 10. I am not using any dot operator here. If you see the dot operator, it is import module. There is no dot operator, and it can use the functions without the module name. And the module name itself not imported. Here it is not imported the module name. Here the module name itself imported, but the module name itself not imported. And the third one is from module import. Imports all names from the modules into the current namespace. It can use all the functions without qualification. Let us see an example from math import star. I am using x is equal to square root of 10. Clear with 3 import statements in statement variants. We have 3 import statement variants. Those are import module, from module import names, and from module import. The preferred variant is the first method, though it requires using the module name each time. That's why the first one is preferred. Import with alias. Let us see. Import math as m dot pi. It will give the value 3.142, the pi value. Local import inside a function. Let us see one more example for this. Define area, radius, import math, return. Area means we have a formula, right? Pi or square. Math dot pi into r into r. I will get the pi r square value. The module is usable only inside the function. It is not global. The next concept is mutable versus immutable and aliasing. Mutable data types can be changed after creation. That is list and dictionaries. In the previous module, I have explained about lists and dictionaries. Once it is it can change it after the creation, which means changes can be happened anywhere after the creation also in the list and dictionaries. Let us see. My list is equal to 2, 4, 5, 3, 6 and 1. Here the 0th index I have 2, but I can change to 9, the 0th index. The 0th index will be 9. I am changing to 9. That's why when I access, it will be in the place of 2, I will get 9. 9, 4, 5, 3, 6, 1 as it is. Only the 0th index will change from 2 to 9. Clear with it? Which is mutable, which means it can be changed after the creation also. That is list and dictionary. Immutable means it cannot change after creation. It cannot be changed. If I want to change, I have to create one more string. Clear? For example, tuples and strings. These are the examples of immutable data types. Let us see an example. My tuple is equal to 2531. I want to change the 0th index. It cannot be changed because once it is created, it cannot be changed. That's why it will show an error. This is example of immutable data type. Aliasing means it occurs when two variables refer to the same mutable object. That is, one list is equal to have taken 1, 2, 3, 4, 6. Two list is equal to list 1, which is referring the list 1. List 2 of minus 1 is equal to 5, which means from here it will be minus 1, minus 2, minus 3 like that. I am changing the minus 1 index to the 5. That's why the list 1 also changes. I am changing the list 2. List 1 also changes. This is how the aliasing works. You can observe here 1, 2, 3, 4, 5. It is changed from 1, 2, 3, 4, 6 to 1, 2, 3, 4, 5. I have changed here. Minus 1 means from here minus 1, minus 2. Clear? Check the memory address using ID. You can easily check the memory address using ID method. That ID of list 1 is equal to, which is equal to ID of list 2. If those two are equal, then it will return the true. Avoid aliasing. Make a copy of the list. Here to avoid the aliasing, you have to make a copy of the list. That is list 1 or list 2. Here list 2 is equal to list 1. I am copying here. When I copy here, when I make a copy, when I change in the list 1 or list 2, it doesn't affect the another list. Let us see. ID of list 1 is equal to ID of list 2. Here I have copied already. That's why it will show false. Because these two are not equal. And list 2 of minus 1, when I change the list 2 of minus 1 is equal to 5, the list 1 stays unchanged. It remains same as before. Here, for nested list, use the copy module to avoid aliasing issues. If you are facing any issues in aliasing, to avoid that, use the copy module in the nested list. Clear with it? Make sure you watch the previous parts and previous modules as well. Thank you very much for watching and share this video with who are struggling in Python programming. Thank you very much for watching.